Hello, hello. This is solving day two. I know you're really missing me, but I appreciate you taking care of business and using your time. We're going to be solving equations just like we did last class, and they have radicals in them. Probably the easiest one on our notes today is example three. So why don't we start with example three? We have a radical, it's by itself. So let's go ahead and get rid of it. To undo a square root or a 1/2 power, we just raise it to the reciprocal. But look what happens when we do this. We end up undoing the square root, but causing there to be 2x squared, x plus 2's being multiplied. Now, when you do that, a lot of people are tempted to say, well, that's x squared plus 4. No, it's x squared plus 4x plus 4. Okay, because we have an x plus 2 and another x plus 2. So we double distribute, and you can see we get 2x and another 2x. And that's what's always forgotten. We don't want to forget that. Okay, now let's solve this thing. Let's see. Ooh, I have a quadratic, so I want to get it equal to 0. I'm going to subtract 2x, and that'll leave me with 2x left, and subtract the 7 from both sides. So my quadratic equation, I'm hoping there's no need for quadratic formula. I don't think there is. Yeah, this factors nicely. Okay, so let's see what we get here. The two solutions are -3 and 1. Okay, but remember, they're not solutions until we check them. We have to make sure that -3 works and that 1 works. So let's check them out a little bit. Let's see, -3, that would be the square root of 1, which is 1. Put the negative, yeah, we've got an extraneous answer here. That's not going to work. When you check your solution, you don't want your square root to be equal to a negative. Okay? Because square roots, their primary root of a square root is a positive. So we have a new solution here for example 3. It's just 1. If we put a 1 in, we get the square root of 9 equals 1 plus 2, and it checks. Done. Okay? Why don't we try example 1 right above this? Checking this out, I'm not a fan of that exponent. I'm going to add 3 to both sides, but I'm a little worried about this exponent. I think I might phone a friend. Yeah, to get rid of that exponent, we've learned to raise it to the reciprocal. But both sides are going to need that exponent because we have to be fair. We have to stick within the algebra process. So do you see why this exponent becomes 1? Exponent with exponent makes 6 over 6. And 6 over 6 is 1. We don't usually write exponents of 1. Okay, now when I take 16 to the 3 over 2, most of you will probably reach for a calculator and you'll get 64. But there is a shortcut you could use. This means square root. The square root of 16 is 4. The 3 would stay with that 4. 4 times 4 times 4, 64. Okay, now square roots are looking good here. We can subtract the 12, divide by 2, and I get a pretty good answer, 26. But again, we need to check for extraneous answers. If I put a 26 in here, I think it would work. I would have to check it. I would get 64 to the 2/3 equals 16. That's the original, and it would check. And that'd be good. All right, example 2. Yeah, we're going to have to counteract that third root. But first, we need to isolate it. So let's get rid of the 2. Oh boy. That gives us kind of an ugly number. 1/2 minus 2 is negative 1/2. Could be written like this. Negative 1/2. So how did we get that? Well, I think it's best just to use a calculator. 1/2 minus 2 is negative 1.5. Negative 1/2 is negative 3/2. So next I have to divide by 8. Ooh, that's not going to be fun. I got to divide both sides by 8. Now, you know what that means though, right? A fraction and division. Yeah, we're going to multiply by the reciprocal there. Okay, so here's where I'm sitting now. The cube root of x minus 3 and negative 3/16. So far, so good. How do I get rid of the cube root? Well, this is like a 1/3 power. If you want to counteract that, take it to the reciprocal of 1/3. But look what's going to happen. We're going to take the both sides to that. Now check it out. When I do that, I will counteract this cube root. So the third and the cube root just kind of erase each other out of there and actually become an exponent of 1. But this one's a little bit ugly right here. Okay? So as we're looking to cube this, notice it's going to be negative. That's right. Negative 3 quantity cubed is negative 27 over, oh boy. Yeah, I'm not looking forward to answering this, but good news for us, we have a calculator. So all we need to do is solve this puppy is to add 3 to both sides. So when I do that, I get a big old mixed number. It's not nice. The calculator, I'll admit it, the calculator did it for me. Okay, and I wouldn't be surprised if some of you are like me, you just wanted to approximate the answer. You know, there's nothing wrong with that, approximating the answer. It was pretty ugly. All right, final problem, the final countdown. I think we have some options with this last problem in example 4. But I would imagine you're not feeling it quite yet. It's kind of complicated with our options here. I mean, it's not a 2 power, or we could make it equal to 0. Is there some kind of exponent we could use? Oh, I think there is. I think there is. I'm going to show you how a math teacher would demonstrate this, though. I think a math teacher would do this. They would say, let's get it all on one side. Let's subtract x to the 1/2 power. And then let's factor something out of there. Okay, what's smaller? Is a 3/4 value smaller than a 1/2? I don't think so. I think if you wanted to factor something, you could try and factor out x to the 1/2. Why don't you try that? Pause the video and see if you can do that, and then see what we ended up with. Aha! Yeah, if we factored out x to the 1/2, when you multiply, you need the exponents to add to 3/4. So if you had the 1/2 sitting here, you'd need a 1/4, because together they would add up to 3/4. And we get lucky here. X to the 1/2 times what is negative x to the 1/2. See, by doing this now, we can now say, well, we've got two factors equal to 0. So all we need to do is take each factor and set it equal to 0. Okay, let's work these. It's a little bit challenging, but it's not too hard for us. How would you get rid of a 1/2 power? Well, you'd raise it to the reciprocal, to the 2 power. And you could see we would end up with this. And I think that would work. I think that answer is approved. When I put it in the calculator and try this out, both sides end up being equal to 0. So I know that this worked when I put 0 in for x. This other one takes a little more work. It's a little more work. I'm going to add 1, divide by 3, and then I'm going to phone a friend. Help me with this. How in the world do we solve for x here? Ugh. Yeah, we're going to raise it to the reciprocal power. This is like a 4th root of x. What's the reciprocal of 1/4? It's just 4. So that'll cancel out the exponent and make it 4/4, which is just 1. But when I take 1/3 to the 4th power, that's 1 to the 4th over 3 to the 4th. I think I've got my answer. So using a calculator, I'm going to plug these in. I'm going to make sure that both 0 and 1/81 are true. I've already checked 0. And guess what? When I checked this one using a calculator, it worked. No extraneous answers. Hey, how are you feeling about this? I hope you're doing okay with the solving. We're not going to do anything that's too much yet. So let's just take our time and try the practice problems today. All right, I appreciate your hard work.